Hello everybody, this is a video about the next experiment, which is called Superconducting Puck, Mechanical Energy Conservation, PNW. So when you log into Pivot, we'll be selecting Mechanical Energy Conservation. And the lab looks like this. The objective here is to make a prediction on how the system will act based on models that we know, so specifically conservation of mechanical energy. So we're going to make some predictions, and then we'll be able to test those predictions with our actual lab. So the video here shows a superconducting puck on a magnetic track. The puck is cooled to negative 196 in liquid nitrogen bath. Then the puck is placed above the track and held in position, and you'll see this in just a minute. Through a process called quantum locking, the puck remains the same height above the track. So we're minimizing friction, virtually no friction, but there still is some friction. So here's what the video looks like. Good, so pretty cool stuff here. So the way this is set up, it says lock, answer, and continue. There's no actual answer. I just wanted you to watch the video before proceeding, so you can do lock, answer, and continue. And then we can go to part one, the prediction part. So you have to complete part one before going on to part two. So be careful with it. You're going to submit your answers before you could go on and actually do the test. So part one is sort of the calculations part of the experiment. How are you going to do the experiment? What will the predicted height be? That sort of thing. So you have to complete part one, and then you can go on again to part two where you actually do the experiment. So predict the height the puck will reach. That's what this is. So the video below shows many trials of a puck being launched. In each case, the video stops before we reach maximum height. And you have some tools here. Meter sticks. You have a option to put a dot on the actual puck that's moving. A few other things. You've got a line here that you could set wherever you want. That sort of like this. Stopwatch. So you've seen some of these before. Some of them are new. Okay. So I'll just move this out of the way. And here's what the video looks like. Okay, so that's just for trial one. You want to actually set it to trial three. Let me do that here. Trial three. So the whole lab is concerning trial three, not trial one. So make sure that you load that in. And then we can let this go. Okay, so we don't see the whole video. We just see the beginning of it. We see the puck moving in this part here. But from this part, you could calculate the speed, right? So if you've got some devices over here. So this is elaborate. A lot of this is up to you to figure out how you're going to do this. I'm just going to kind of walk you through and give you some hints. So from the first part here, you can calculate the speed, right? You know, after it leaves the person's finger, before it starts going up this way, you can calculate the speed. How can you do that? Well, you know, you've got some measuring devices here. You got a stopwatch here. So in this horizontal part, you could actually calculate how fast the puck is moving. Okay, I don't want to say too much about it. This is your lab to do, and you've got a lot of experience now. So this lab, you're on your own a little bit more than the previous labs. Okay, so just based on this part, how fast we're going, how high can we actually go? And really, you have to consider the center of mass of the puck. So let me back the puck up. Okay, so here's the puck out of the person's hand. The center of mass of the puck is located in the center. Something like that. So you want to know how high the center of mass of the puck will go. You know, when it reaches its highest point, somewhere over here, you've got the leading edge, the trailing edge, But really, to use conservation of mechanical energy, we're going to have to use the center of mass. So how high will the center of mass go? And you've got these different tools to play around with. You could maybe say this is your baseline, something like this. How high are you going to go? You can use this meter stick here, put it this direction. So when you actually measure it, keep that in mind. You can calculate how high it goes. And again, you're looking at the center of mass. Okay, so let me read through a little bit more of this for you. Your goal is to predict the maximum height the puck will reach. Select trial 3 from the video. You'll make measurements from the video that will allow you to predict the maximum height. So really, based on the initial speed, how high are you going to go? Now, if you try to do this with forces, it can be done. But remember, as the puck goes this way, gravity's still pointing straight down, but this is a curved track. The component of gravity back down the incline keeps changing. So through calculus, you could actually do this with forces if you knew the shape of the track. Luckily, we have a different way of solving this problem. It's called conservation of energy, and I'll look at that in more detail in just a minute. Okay, so this is your experiment. You'll come up with your own method to achieve the stated goal, which again is to predict the maximum height. So you will need to address the following points in your summary. And there's 5 points here. So what you'll do in this lab is, do this on a piece of paper, however you want to do it. Take a picture of it and then upload it. And I'll show you how to do that in just a minute. But make sure that you include these points. And the easier way for us to grade it is if you put number 1, describe in general how you go about finding the maximum height. Number 2, then answer this question: what measurements will you make to find the maximum height? And be specific. You're sort of outlining what your experiment's going to be. Number 3, include whatever data you recorded and make it clear so we can figure out what you're talking about there. Show all the calculations that you made. Clearly indicate your prediction for how high the puck will go. And what assumptions did you actually make for this experiment? Things along the lines of, well, we assumed that there was no friction, but really maybe there is some friction. Okay, so you'll need to upload your experimental summary, addressing all these 5 points. Okay, here's some things to keep in mind. Kinetic energy is 1/2 mv squared, and gravitational potential energy is mgy. Make sure that you measure all distances in meters, so you'll have to convert them to meters. The measuring device that you saw was in centimeters. All masses should be in kilograms, and the mass of the puck is 0.08 kilograms. Okay, and then once you address all those points, make your prediction, then you can upload them here. And the way to do that, take a picture of your work. So probably the easiest way is just with your phone. Take a picture of your work, and then you can upload it here. Okay, so I click that on mine. You click the picture thing here wherever you saved it, desktop or whatever. Click there, and then you can upload it. Okay, so let's look at this, the theory behind this a little bit more. Okay, so here's the puck going up a track. As you can see, I've indicated the center of mass of this block. We want to know how high the center of mass is going to go. So we're starting down here with some kinetic energy. So the initial kinetic energy is 1/2 mv squared. Now the v, it's up to you to measure the v, as I've sort of indicated before. And then the puck is going to go up the track to a maximum height. So something like this. So you want to predict how high the center of mass goes. So when I was talking before about the reference line, let me change this to a different color. So if this is a horizontal line, you want to know how high the center of mass goes. So really you want to be able to predict this height here. Okay, and be able to do that by just knowing the initial speed. So what do we have up here? Well, at the highest point, the puck is not moving anymore. So here we just have gravitational potential energy at the highest point. So gravitational final, and this is mgh. So essentially we're taking kinetic energy down here at the bottom, and converting it into gravitational potential energy. So the kinetic energy becomes gravitational potential energy. So this, I think the lab calls this initial. This is gravitational final. So this 1/2 mv squared is equal to mgh. Okay, so from this you should be able to figure out what h is, right? You know everything else. Do a little bit of math and you actually see that the mass cancels out. The mass doesn't come into play here. Now what assumptions are we making? Well, we're assuming that we're starting with kinetic energy and all of that is turning into gravitational potential energy. So whether that's true or not, you'll find out by doing the actual experiment. So that's the theory behind it, taking kinetic energy, turning it into gravitational potential energy. Okay, let's go back to the actual lab. Okay, so now I think you should have enough information to complete this little summary part here, and you'll be able to figure out what your prediction is going to be. Upload it here again, and then you have to click lock your answer and continue. And then you'll be able to actually check your prediction. And that's this second part here. Whoops, I have to do this first. So make sure that you've uploaded it before you submit your answers because you can't go back. And then here, you could actually test it. So again, make sure that you go to trial 3, load. And now the video will play all the way through, and you could do the actual measurement of the height to the maximum level. So when you hit the maximum level, you have to pause it. You can play around with it a little bit here. Okay, it was still going up there, coming back down. Okay, so somewhere in there. Okay, so good. So this is the maximum height. Let me redo it. Back here. So, okay, here we go. Excellent. So this is the same trial. You know where you started at. So use your tools here. You've got the reference line. You know, set that to right in the middle of the puck. And then once you get up to the highest point, stop the video. I would recommend maybe putting the dot right in the center of the puck once it's stopped, and then measure that height just like in the theoretical part that we went over. Okay, and then you can measure the actual height, and you'll then compare that to what you calculated in the calculation part. Okay, so measure the height. You put that here. Compare the measured height to the predicted height. Figure out the percent difference there. Is the actual height greater or less than your prediction? Offer a reasonable explanation. That sort of thing. So make sure you go through and answer these questions. Okay, have some fun with it. Again, you're by this time of the semester, you're in the position to sort of design a little bit of the experiment yourself. Okay, have some fun with it and talk to you soon. If you have any questions, email your lab instructor.